Hey everybody, today we'll be talking about iterating expectations and variances. This is a project for the course Matemáticas de Riesgo or Risk Theory, and the team is conformed by three actuarial science students named Juan Pablo, Francisco, and myself, Luis Fernando. So let's see, what is the problem that we want to solve today? You have been selected by the Dirección de Compromiso Social to analyze tobacco consumption habits at Universidad de Anáhuac, Mexico. You have been given the following data about the amount of smoked cigarettes in a day. So we have the data for men and for women. So about men, we know that the mean of the smoked cigarettes in a day is 6 and the variance is 64. And in the case of the women, we know that the mean is 3 and the variance is 31. So these are clearly some parameters that will be used in the future. Then we know that the number of men in the sample of size n is binomially distributed with parameters n, that is the sample size, and 0.4. Determine the mean plus the standard deviation in a sample of 8 people. So let's see what is that we have learned in risk theory course until now. So in risk theory, normally we use n as a random variable for frequency, x for the random variable for severity, and s as the random variable of the aggregate claims. And what we want sometimes, or most of the times in risk theory, is to get the expectation and the variance of the aggregate claims. So the expectation of the aggregate claims can be calculated as the expectation of the severity multiplied by the expectation of the frequency. And the variance of S can be calculated as the square of the expectation of the severity times the variance of the frequency plus the expectation of the frequency times the variance of the severity. And now we will see how this is or is not related to the problem we're solving. Maybe you will think it's not related, but it is, because these formulas or these calculations were gotten using the following methods. So we are going to try to get the expectation of variance, the expectation and variance of a random variable in the problem we're trying to solve. So we will return a little bit to probability and see that the law of iterated expectations says that if we have s and x that are random variables, then the expectation of s will be the expectation of s given x. And then we also have the law of total variance that says that if we have s and x that are random variables, then the variance of s can be seen as the expectation of the variance of s given x plus the variance of the expectation of s given x. So now, knowing this, having this formula, we're going to go and solve the problem.
Hello there. So, let's resolve the problem, shall we? First of all, let's remind the table in which we could find the mean and variance of the men and women. Let's just remember that there are 8 persons and 0.4 of a probability that it was this way. Okay. Now, okay, so let x. We're going to solve this problem. We're going to use the law. I'm gonna write it right down. Law of iterated expectations. So let s and x be a random variable, then we can estimate the expected value of the random variable like this. This will be fundamental for our problem, and also we'll need the law of total variance, that with the same random variables, let x and s be two random variables, then we can rewrite the variance of the random variable like this, like the sum of the expected value of the variance of s given x plus the variance of the expected value of s given x. This will be the two theorems we'll be using for our problem. Let's compute it on Excel.
Okay there, thanks. Now we're gonna continue by making the Excel spreadsheet that it will be make it a little bit easier to understand, and it will make a point on how to compute this problem. First, I wanted to remind you the table that we had of the men and women with its own mean and variance. And also, I want to remind you that this is a problem where the number of men in the group is gonna be distributed in a binomial way with a sample size of 8 and parameters of 0.4. So now what we're going to do is with the variables s, that we're going to put like the number of cigarettes smoked, that's the answer we're searching for, and x as the number of men in the group. So to begin with, we'd want to know the expectation of men in the group. That we know as it's a binomial, that it will be n times p. In this case, it's give us 3.2. And we know the variance is n times p times q. And as it's a binomial, we know the q is the complement to 1. So it could be computed as the expectation of x times the complement to 1. So now that we have the expectation of number of group, we could go and seek for expectation of number of cigarettes smoked. So here we know about the theorems that my partners gave before, that the expectation of that would be the expectation of s given x. This we can know it by multiplying the mean of the men times the number of men plus the mean of the woman times the number of women. Here, as you can see, I'm here for the number of women, taking the size of the sample minus the expectation of number of men in the group. Now, for the variance, it's quite more difficult. We will use the expectation of the variance of s given x plus the variance of the expectation of s given x. Now, we can divide it in these two blue groups here. So let's start with the expectation of the variance of s given x. We know that that would be the variance of 6 times x plus 3 times 8 minus x. How we know this? The 6x comes from the mean of men times the expectation of x plus 3 times that is the mean of woman times the sample size minus the number of men in the group. So by doing that, it would be a variance of 24 minus 3x. We know that the variance of 24 is 0, so we can leave it apart. So that would be 0 plus the variance of 3x. And now, to get the 3 out of there, is 3 squared, that gives us 9, times the variance of x. And as we already have computed the variance of x, it's quite a simple multiplication there. Now, with the variance of the expectation of s given x, we have to first seek for the expectation of s given x. That we could compute it as 64x plus 31 8 minus x is quite as the same as the variance that it's given ahead, but the difference is we're going to use the variance instead of the mean for the parameters here. So that will give us the expectation of 248 plus 33x. That will give you 248 plus 33 times the expectation of x, and that's 17.28. Now, using the theorems that were given before, we know that the sum of these two results that we obtained before are the variance of s, and that's 370.88. So here are the main results that we needed, and now we have the expectation of number of cigarettes smoked and the variance of that. But the problem asks us that what was the mean plus the standard deviation of number of cigarettes smoked. So that we will have it as the sum of the expectation of s plus the square root of the variance of s, that's the standard deviation, and that's how we could have computed our problem.
Now
Thanks.
that we have solved the problem, let's talk about the main things that we learned with this video. So, understanding the different probability or mathematical theorems or laws can always be a great tool for us actuaries to work in a more efficient way and always understand what we're doing. In this case, both laws that we saw, the one on variance and on expectation, were basic to understand and solve the problem. And like this, we can find many other solutions or cases where this is absolutely useful. We can see how different courses or different subjects are directly related, such as well, risk theory, probability, statistical mathematics, and many other subjects in our academical career. And to end with this video, we would like to thank you for your attention and show you our references if you want to check any of them. They are right here, so thank you very much, and we hope you enjoyed it.